So this question says that we have a solid uniform sphere of radius r and mass m, and its rotating or inertia about diameter is given by 2/5 mr squared. Light string of length 3r is attached to the surface. I'm going to highlight that right now so I don't forget that it's to the surface, and is used to suspend the sphere from the ceiling. The rotational inertia about the point of attachment is what? All right, let's draw some pictures. So we have our sphere, and it's rotating around a rotational axis given here. What I'm going to do is I'm going to draw this in a different color. It seems weird that I drew the rotational axis on the side, but I have a specific reason. It's because I'm putting the ceiling up here and I'm attaching this distance here. So this distance from here to here is 3r. And this distance from the center there is 1r. So I want to know what the moment of inertia is around a rotational axis that's in the x direction. Now, originally ax, but I'm changing my rotational axis. So I know that my initial moment of inertia is given by 2/5 mr squared. I'm going to use the parallel axis theorem, which says that my new moment of inertia is going to be my center of mass moment of inertia, this guy, plus m times d squared, where d is how far I move the axis of rotation. So my d is that length right there. So when I substitute in the values, I get 2/5 mr squared plus m, the mass of the object, and the distance it moves the distance of 1r plus 3r's for 4r squared. So 2/5 plus 4 squared, 16 mr squared. I had mr squared and mr squared, coefficient of 4 squared, which is 16, and the other coefficient is 2/5. Oh, this is going to be a big number. So this is going to be 2/5 plus 16 is going to be 0. Give me a 3, 5, 80. 80/5 mr squared. Doing this without a calculator, so you'll have to forgive me for being a little bit slow on this. I get 82/5 mr squared. So I look at my answer choices, and answer choice E is the right one. And it really, one of the very common mistakes people will make is that they attach it to the wrong spot. They think that we move a distance of 3r, but we really move a distance of 4r because we go from, we attach that string 3r of length to the outside edge, not to the center of this. So a little bit subtle in terms of its wording, but not a bad problem to solve.